look at the bonus problem, 16C. All right, so let's talk first. The question is asking how much leftover aluminum ion we have. Well, they say how much leftover ion do we have? We know in this chemical reaction that the aluminum, the sulfate, is going to be the excess reagent, because we know that the sodium hydroxide is the limiting reactant. We found that out in the previous episode. So let's figure it out together. All right. So I start out with the limiting reactant, the volume, and I figure out using the molarity here as a conversion factor how many moles of sodium hydroxide I have. Using that moles of sodium hydroxide and the balanced equation, I figured how many moles of aluminum sulfate react with it. Okay, so this is how much reacted, and we know since they gave us a lot of sodium hydroxide. They gave us a lot of Al2SO43 that we have extra. Okay, so because the sodium hydroxide is the limiting reactant, let's figure out how much we started out with, because we just figured out how much reacted. So we started out with 2.76 grams of aluminum sulfate, and we figured out the moles of aluminum sulfate using the molar mass. And this is how many moles of aluminum sulfate we have. Cool. So I set up a little table here. I've got the moles of what we started out with, okay, minus the moles of what reacted, and I've got this number of moles of aluminum sulfate. The question, though, is how many moles of the ion, and not worrying about the spectator ions. So let's just focus on the ions that are important to this reaction, which is aluminum. So let's see. So what I did was that I know that I have this many moles of aluminum sulfate. And if I figured out for every 1 mole of this, there's 2 moles of aluminum. So let's multiply this guy by 2, and we get moles of aluminum. And then to find the molarity, it's just the moles divided by the volume, and it's additive, so I added up those numbers to 210 milliliters, or 0.210 liters, and I get 0.0431 molar aluminum ions. That's how you do it.